All right, those linear equations are for the birds, huh? We did the linear equations of one variable, solve for x, there's a unique answer. We did linear equations of two variables, systems, two equations, two unknowns, an x and a y, and we found them. Well, now we're going to move beyond linear. You know, what made it linear to begin with? You know, 2x plus 3 equals 5. What makes this a linear equation is the exponent on our x here. So there's a little exponent of 1 on that x. We just never write the 1. That's linear. The minute we throw something else in there, like an x squared minus 4 equals 0, now it's not an exponent of 1 anymore. Now this has got an exponent of 2. We call this a quadratic. Quadratic. Okay? If we had an x cubed, it's called a cubic, etc. They're special names. These all fall under the category now of polynomial equations. Okay? We'll take a look at some of these. Some of the techniques for solving these higher order equations are the same, and some are different. All right, so let's talk about a quadratic equation, which involves a square, right? Let's just use that one I wrote there. X squared minus 4 equals 0. You know, when I teach my algebra classes, I call this an easy quadratic. Okay, I annoy my students by throwing that word easy in there. And you know what? I always do math is fun. Haven't done that in a while. Shame on me. Fractions rule. I got to really squeeze it in now. Pardon me for not doing that as much as I should. All right, where was I? Easy quadratics. Why easy? What am I talking about? Well, if I asked you to solve for x squared, just like we solved for x in the good old days, solve for x squared. Well, you'd say, I didn't show the step, but you'd add 4 to both sides, right? And then you'd say x squared equals 4, okay? And now you say, how do I turn an x squared into an x? Well, I can take the square root of x squared. So I'm going to take the square root of both sides. Okay, equation solving gives us a lot of little powers and techniques that we didn't know we had. We can add something to both sides, subtract, multiply, divide. We can square both sides. We can square root both sides. The square and the square root, they annihilate one another. I like to say annihilate. It sounds cooler. They annihilate one another. Gone. It's just an x now. And the square root of 4 is 2. Now, there is a little bit more to this story, but I don't see it showing up on your exam. There's really 2 answers. There's a positive 2 and there's a negative 2. Wow, huh? Really? Why? Well, what happens if I take 2 and I square it? I get a 4. And what happens if I take negative 2 and I square it? I also get a 4. So I can start in 2 different locations. I can do this thing I call square, and I get 4 for the answer. So if I'm going the other way, who's to say I go to positive 2? Maybe I go to negative 2. So there really are 2 solutions, but I haven't seen that on your exams. They're just looking for the positive root, called the principal root. All right, so that's all we need to know. We'll just look at that. So we take the square root of both sides. Okay, x squared is 9, okay? Square root both sides, x is 3, right? I mean, pretty straightforward. Ultimately, we're taking the square root of both sides. Now, maybe we have to do a little baggage, a little extra work. Maybe we've got 4x squared equals 20. Well, first I have to divide by 4. And now I've got x squared equals 5. And now I square root both sides. Uh-oh, what's the square root of 5? Well, it's some irrational number, some big old goofy decimal. We'll just leave it in math class as the square root of 5. Maybe there'd be some choices where you'd see some decimal in there, and then you just put it in your calculator and get it, okay? All right, what about this one? 2x squared minus 5 equals 0. This has got a little more baggage. First, I add 5 to both sides. 2x squared equals 5. Then I divide by 2. X squared equals 5 over 2. Then I square root both sides, okay? X equals radical, what we call radical is the square root of 5/2, which your exam would probably leave it at that. There are some things that can be done to clean this up, so to speak, simplify it. We call that rationalizing the denominator. There are things you can do to clear that up, and I might as well just do it now that I've said that. This is, after all, just some fraction, right? And you can always multiply a fraction by 1, and it's still anything by 1, and it's still the same anything, right? Just how do you 1 can be represented a lot of different ways. Well, here's how I'm going to represent 1. I'm going to call it radical 2 over radical 2. That's a 1, isn't it? It sure is. So now what do I have? Now I've got x equals radical 10 on the top and radical 4 on the bottom. But guess what? Radical 4 is just good old 2. So radical 10 over 2. Okay, I don't think your book goes, or the exam goes quite that far. It might, I suppose, but I don't think so. Okay, set these up, solve them. We solve them by ultimately taking the square root. Now, what if you have something like this now? Now we have to resist temptation. Okay, let's resist temptation, shall we? If I have x minus 5 squared equals 16, you might, I'm not accusing you of anything, but you might say, aha, a binomial squared, that's like that FOIL process, right? That really means x minus 5 times x minus 5 equals 16. I know how to do that, the old FOIL trick there. We do the first, and then that, and then that. Okay, blah, blah, blah. We combine some like terms. And then we're sitting here. We got an x squared and an x. So what we'd have to do is when you have a more traditional quadratic equation, we'd want to get the 16 over to here. And we want to make it equal 0. Now we're going into the world of what we would call the quadratic formula, or some other techniques to solve a quadratic. We're no longer easy quadratic. Okay, we just made it hard on ourselves by doing all this work. I said I wouldn't accuse you of doing this, but you might want to do that. And not that it's wrong, but it just made it so much harder. Okay. We have something squared equals 16, right? Something squared. Well, let's take the square root of it, shall we? Square root. Now I just have the something, not the something squared, because the square and the square root annihilate one another. And I've got, again, in math class, I've got two answers here. I've got a positive 4 and I've got a negative 4, and then we finish it up both ways. But for your purposes, we'll just call it one answer. We'll call it a 4. Not quite done, almost, all right. Add 5 to both sides, x equals 9. Okay, much easier. Take the square root of both sides. Okay, easy quadratic. Okay, the Pythagorean theorem kind of uses some of this. Remember that now? If you ever had a geometry class, Pythagorean theorem. It's a classic, oh so important thing on a geometry dealing with right triangles. Oops, let's pretend that's a triangle, not a little extra leg there. All right, a right triangle. One side I'll call A, one of the sides. The other side I'll call B. This long side has a name called the hypotenuse, remember? Call that C. This is a 90-degree perfect corner angle, there's a special relationship between these sides, and that relationship is A squared plus B squared equals C squared, okay? Every time. So if you know 2 of the 3, you can find the third, okay? So if somebody said, A is 3 and B is 4, what is C? Okay, here's a classic right triangle. A 3, 4, it's a 5. 3, 4, 5 right triangles. It's one of those you just remember. But let's plug it in and let's say 3 squared plus 4 squared equals my C squared, right? Well, that's 9 plus 16 equals c squared. So 25 equals c squared. I square root both sides and I get c equals 5. Okay. I can use this to find any missing side that I want out there. Okay, what about, now what about this one? What about, what if one of the smaller sides is missing? Yeah, I'll just keep the numbers easy. What if one of the smaller sides is missing? A right triangle, a 3, 4, 5 right triangle. Let's say I know the 5 and I know the 4, but I don't know that side there, 3. Now, it doesn't matter which one of these you call A or you call B, but just to be consistent, I call that one A and that one B. The long diagonal side must be your C, though, okay? So B is the unknown, right? A squared plus B squared equals C squared, but B is now my unknown. So if I do a little algebra here, I'll subtract a squared from both sides and I'll get b squared equals c squared minus a squared. But I want b, so I square root both sides. B equals the square root of c squared minus a squared. And there's really no way to shortcut that. We just have to leave it like that. All right, so b equals the square root of what? C squared, so 5 squared minus 4 squared. So b equals 25 minus 16, the square root of that, b equals the square root of 9, and we get 3. Okay, so we can always use that formula on these right triangles. Higher level, okay, that was quadratic, x squared. What about something beyond that? What about cubic? X cubed equals 64. Okay, well, we're going to take what we call the cube root of each side. That's got a little 3 on the ledge there. We didn't have anything on the ledge for square root. We didn't need to. Any other root, you have to show an index. What root are we talking about? We're talking about the cube root in this case. So the cube root and the cube wipe each other out. Now there's some caveats to worry about with whether or not you have a negative number underneath the root. If you have a negative number underneath an even root, it's trouble. It takes us into the world of imaginary numbers. A negative number underneath an odd root doesn't do that. But again, I saw none of that on your practice exams. We just need to take the cube root of 64. What times itself again is a 64. Well, 4 times 4 is 16, times 4 is 64. It's a 4. Okay. Again, in a multiple choice situation, in a pinch, you know, you're going to have choices A, B, C, and D, and you're going to have, you know, A is 3, B is 4, C is 5, you know, whatever. You can just try that, you know, take 3 times 3 times 3, and see what it is. 4 times 4 times 4, 5 times 5 times 5, 2 times 2 times 2. One of those has got to be the right answer, right? So you can kind of figure it out backwards even when you have a multiple choice situation. Fourth power, quartic equation, we call that. The x to the fourth power equals, you know, 16. What do? Well, we take the fourth root of both sides. Okay, the fourth root and the power 4 annihilate each other. We just have x. The fourth root of 16, something times itself times itself times itself is a 16. That's a 2, right? Because 2 times 2 times 2 times 2 equals 16. Fourth root of 16 is a 2. Okay, so that's really it on these easy equations. Now, if you have extra baggage, if we had x to the fourth plus 3 equals 16, it becomes something more. It requires us to take the 3 away first. Then we have x to the fourth equals 13, and this is not going to be a pretty number. When we try to take the fourth root of 13, we're going to get some goofy decimals. Okay, it gets even more complicated when we have not only a high order exponent, but what if I started throwing stuff like this in here? You know, well, what if I had that? You know, whatever equals 0. Now there's a lot more to the story on something like that. You're not going to see anything like that on your exam. Okay. All the ones I saw fell into the, what I call the easy category. Ultimately, you're taking a root of both sides, square root, cube root, fourth root, ultimately taking a root, and then you've got your answer. Okay, so that's pretty good for that kind of stuff. So this video now concludes what would be the third night of class if we were live in the classroom. So the remaining videos are going to be one more new material for a little bit. The fourth night of class would consist of about half of the time new material, and then the other half going through another practice exam. So there's not a whole lot of new material left, I guess, which is good. And then you'll see there's another practice exam in the later videos. All right, very good. Thank you.